Hey everyone, today we're going to be talking about homework number 16, and that will be out of sections 11.1 and 11.2, which we were talking about patterns and sequences from class. So just jumping right into this thing, to start out from section 11.1, the first section I have you guys, you are going to be doing problems 3, 5, and 8, which I just give you a set of numbers or a sequence of numbers, and you're trying to find the pattern and then fill in the next three terms. So I'll just do number 2 out of this problem set. So on number 2, I see 4, then 8, then 16, 32, 64. So when you start looking, it's always good to start seeing if there is adding or subtracting first. If there was, I know I'd be going up by 4 every time, but when I look at the second set of terms, I'd be going up by 8. So I actually know, unfortunately, nope, definitely not adding. But then, always the next good check to go to is multiplication. To go from 4 to 8, I'm multiplying by 2. Go by 8 to 16, hey, there's my pattern. I'm going up just multiplying by 2 each time. So, if I continue this pattern for the next 3 terms, I will then get 128, then I'll get 256, and then I'll get 512 as my next 3 terms of this sequence. Alright, moving on, you guys then have questions 12 and 14 out of the next problem set, so let's just go ahead and do question 13. So on question 13, I'll just write out the first couple terms of the sequence. I've got 43, 41, 39. Hopefully you're seeing already, hey, I'm just going down by 2 each time. So to write our recursive, our recursive formula, all we're going to do, remember, recursive formulas are going to deal with the previous term. So I'm going to say a sub n, or whatever term, the nth term, it could be the 10th, the 15th, whatever it might be, is going to be equal to the term before it, or a sub n minus 1, and then that thing minus 2. So whatever I had before, I'm going to subtract 2 from it, and hey, that's going to leave me at whatever term I'm trying to find. So the last problem you guys have out of section 11.1 would be problem 46. On this one, it says use the given rule to write out the 4th, 5th, 6th, and 7th terms of each sequence. So just to make things easy, let's go ahead and do 45 together. So 45 tells us, hey, a sub 1, or your starting term, is going to be negative 1. And then a sub n is equal to the previous term, or a sub n minus 1, plus n squared. Okay. Alright, so since we've been given a sub 1, I can now find a sub 2 using my recursive formula. So a sub 2 is going to be a sub n minus 1, or a sub 1, plus n squared. And on this one, we're saying n is 2. So I'll say 2 squared. So obviously here, a sub 1 was given to us, so that's negative 1. 2 squared is 4. And then when I do negative 1 plus 4, I'll end up with a sub 2 equals 3. So with recursive formulas, the cool thing is I can start building all of these. The kind of not so great thing, if I'm trying to look for the 4th, 5th, 6th, and 7th terms, I need to at least have the 3rd one to build the 4th one. Then I need the 4th one to build the 5th one. So that's why I started by building 2, because I need 2 to get to 3. So now I can just keep following this pattern. I'm going to build me a sub 3. A sub 3 would be the previous term, or a sub 2, plus whatever n is. Here it's 3. Squared. And then here, obviously, a sub 2 was 3. 3 squared is 9. So I will get a sub 3 equals 12. Alright, as we keep going, now I'll build a sub 4. A sub 4 is going to equal a sub 3, which we just figured out was 12. And then n squared plus n squared, or plus 4 squared. So that's going to get me 12 plus 16, or 28 for a sub 4. So there's one of the points I needed. Then I go to a sub 5, which would be a sub 4, which we just found, plus n squared. N is 5 here. So I'll get 28 plus 25 for a grand total of 53. Then as we keep going, a sub 6 is going to be the previous term, plus 6 squared, or 36. And that's going to get me 89. And then for our last one, we'll have a sub 7, which is going to equal our previous term, plus 7 squared, or plus 49, which will get us 120 plus 16, or 136. And there is our recursive formula in action, getting us all the way up to the 7th term of the sequence. Alright, so now let's jump into section 11.2. So to start off with 11.2, you guys have questions out of the first set, which would be problems 1 and 5, where we're just asking, is the given sequence arithmetic? If so, identify the common difference. So here, let's start with 2. So problem 2, really on this one, you just need to remember that arithmetic sequences just means that you're either adding or subtracting the exact same number from it. So on 2, I get 10, 20, 30. I'm not even going to keep going. Clearly, I'm going up by 10. So this is arithmetic, so I'll put yes. And the common difference, or D, is 10. Positive 10, because I'm going up by 10 each time. So if you see, if we have one like, I don't know, let's look at 4. 4 says 0, then 1, 3, 6. So on this one, I'm going up by 1, and then I'm going up by 2, then I'm going up by 3. So even though I'm adding each time, it is not arithmetic because I'm not adding by the same thing. It would also not be arithmetic if I was multiplying by something each time. If you remember back to the first problem set from 11.1, I had a sequence that was being multiplied by 2 each time. That would not be arithmetic. You've got to be adding by the same number each time. Alright, moving on to questions for you guys, 11 and 17. We find ourselves trying to find the 32nd term of each sequence given. So remember, the easiest way to do this, we could use our recursive formula, but that would be a pain. We'd have to find the first, second, third, all the way up to the 31st term before we could find the 32nd term. Don't do that. That's going to obviously take way too long. If you remember from class, we have an explicit formula. The explicit formula is as follows. A sub n equals a sub 1, your initial point, plus whatever your n is, minus 1, times your common factor, that thing that you're going up by each time. So let's go ahead. I have you guys doing 11 and 17. Let's do 20. Okay, so problem 20. I see a sequence of 13, 17, and then 21. And I'm going to stop there because I'm already seeing this pattern. We're obviously just going up by plus 4. So that tells me, hey, that's my D value in this equation, is 4. So now I can just plug everything in. So from the problem, I know I'm looking for the 32nd term, or I'm looking for a sub 32. When I start plugging in here, I know that the first term, a sub 1, is just this 13 from the very beginning of the problem. So I put 13 there. N is just whatever term we're looking for, or the 32nd, minus 1. And then we said that D was just going to be 4 here. So now we just gotta basically follow the order of operations and solve this thing. So first thing I have to do is parentheses. So when I do 32 minus 1, I'll get 31 here, just drop everything else down. Then I see multiplication right here. I'm going to get 124 when I do that. Bring down my 13. And then when I add 13, I'm going to go ahead and get 137 here. So that will be a sub 32. Bada boom, I've got my 32nd term. So the big thing to realize here, the recursive formula, even though it's kind of nice, it would take forever to get there. If I had given you the 31st term, it would have been super simple. It would have been even a little easier to calculate than this one. But since I only gave you the first 4 terms, that would have taken forever. So now here, this is why the explicit formula becomes so important and so easy to use. Alright, moving on, I have you guys next doing 23 and 24, which would be finding the missing terms of each arithmetic sequence. So I'll just go ahead and do, let's say, 22 here. So, big thing to realize is we know we're going up by the same thing each time, so really all you're doing is finding the mean, the arithmetic mean, or the average. So, if you remember, to find an average, you're going to add up all your data points. So here on 22, I gave you the numbers 14 and 28. When I add those together, I'll get 42, and then you just divide by however many data points you had. So I had 1, 2. So I'm just going to divide this thing by 2, and I'll get 21. That'll be the missing term, and you can always check. If I added 7 to 21, I'd get to 28, and if I subtracted 7 from 21, I'll get to 14. So I know I'm going up by a factor of 7 each time here. Alright, the next problem set has you doing number 46. That's the only one I have you do in this one. And what we're doing is just finding the 17th term of each sequence. So I'll go ahead and do 47. 47 is pretty similar to 46. So on 47, I gave you a couple pieces of information. A sub 16 is equal to 18. And I told you that the difference is -3. Basically, we're going down by 3 each time. So this one's pretty simple. We're technically using the recursive formula of a sub n equals a sub n minus 1 plus whatever d equals, or just logically thinking, if I gave you 16 and I'm trying to find a sub 17, I'm just going to take what I have and I'm losing 3 for each value, so I'm going to go down by 3. Which tells me that a sub 17 is just 18 minus 3, or 15. Alright, for your very last one, I have you basically filling in the blanks of some missing terms of a sequence, and I have you guys doing 63, so let's just go ahead and do 64. So on 64, I gave you 10, blank, 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 and then -11.6. So if you read through the little bolded part, it gives you a little kind of hint at the end that says, if you found the mean of these two, you would actually be finding this term right in the middle here. So let's go ahead and do that really quick. So remember, to find an arithmetic mean, all I'm going to do is 10 plus -11.6. When I do that, I'm just going to get -1.6. And then you're going to divide that thing by 2, or get me -8/10. So I know that's what goes into here. 0.8. Okay. And then I can just keep on going from there. So what we're going to do here is now I'm going to find the mean of these two things. So I'll do 10 plus -0.8. That's point, sorry. And that's going to get me 9.2. When I divide by 2, that's going to get me 4.6. Okay, and then last I'll do the same thing. Move this down. I'm going to do the same thing with my third and my fifth terms, because if I find that mean, I'll find the fourth term. So I'll do negative 8/10 plus negative 11 and 6/10. When I do those, I'll get negative 12 and 4/10. When I divide that by 2, I'll get negative 6 and 2/10. So that's what goes in this last little box there. So basically, you're just finding a mean 3 times and just plugging in those middle numbers. Alright, that's all for today. If you have any other questions, please feel free to email me, and I'll get back to you as soon as I can.